In Unit 10 through 11, the only formula that will be given to you is the formula for the sum of an infinite geometric series, and partial sums are not going to be included, so you're not going to need to worry about those. You do need to know the term formulas, however. All right, in 97 through 118, we're determining if a sequence is arithmetic, geometric, or neither. And so remember that a geometric sequence is one in which each term is the previous term multiplied by a constant called r. In this case, if we look at the ratio of terms, -1 divided by the term before it is -1/2, and then 1/2 divided by the term before it is also -1/2, and -1/4 divided by the term before it is also -1/2. So this is a geometric sequence with a ratio of -1/2. In 98, if we subtract terms, 5 minus the term before it is -6. -1 minus the term before it is also -6. And if you do this with each term, subtract the term before it from it, we'll get a common difference of -6. So this makes it an arithmetic sequence with a common difference of -6. In 99, if I look at ratios of terms, 4 divided by the term before it is 4. 9 divided by the term before it is not 4, so this is not geometric. If we look at differences, 4 minus the term before it is 3, and 9 minus the term before it is 5, so it's not arithmetic. This is going to be a neither. In 100, if we give these terms a common denominator, 7/3, 2/3, -3/3, -8/3, we can notice that the numerators are decreasing by 5. So this is an arithmetic sequence with a common difference of -5/3. In number 101, if we look at ratios, 4 divided by 5 is the second term divided by the first one. 5 divided by 4 is the third divided by the second, so this is not geometric. 4 minus 5 is -1. 5 minus 4 is +1, so it's not arithmetic. This is going to be a neither. In 102, this is going to be a geometric sequence, and the reason is that if I take any term and I divide the term by the term before it, I get x squared. X to the 7th divided by x to the 5th is also x squared, and so on. So this is a geometric sequence with a common ratio of x squared. In number 103, if we have an arithmetic sequence, and we have the third and fifth terms, we can relate the fifth and third terms in the following way. The fifth term is equal to the third term plus, since it's arithmetic, 2 differences, which is 2 is the difference between the term numbers. So our fifth term is 11 and our third term is 5. Solving this equation, we get 6 is equal to 2 times d, and d is equal to 3. From here, we need to find the 15th term. So the 15th term is equal to the fifth term plus 10 d's. And the fifth term is 11, and 10 times the difference is 10 times 3, so that's 30 plus 11 is 41. In 104, we can find the first term in a geometric sequence. Remember, a geometric sequence, we multiply by r to get from one term to the next. So with that in mind, the 7th term will be equal to the 6th term times r to the first power. So the 7th term is 16, the 6th term is 8, and if we divide, that's going to give us an r value of 2. Now if we want to find the first term, we can relate the 6th term to the first term. The 6th term is the first term times r raised to the 5th power. So 6th term is 8, and the first term is unknown, and r is 2. So that gives us 8 is equal to 32 times a sub 1. Dividing a sub 1 is 8 32nds, which reduces to 1/4. In 105, we're given an arithmetic sequence, and so we can observe here that the common difference is 4 because we add 4 to get one from one term to the next. So in that arithmetic sequence, the nth term is equal to the first term plus the common difference times n minus 1. And so our nth term is equal to the first term 20 plus the common difference, which is 4 times n minus 1. Now, if I replace a sub n, the value of the term, with 464, then we can solve this equation to find n, the number of the term. So subtract 20, that's 444, is equal to 4 times n minus 1, and divide by 4, 111 is equal to n minus 1, so n is 112, so it's the 112th term. In 106, we're given that we have a geometric sequence with a first term 2 and a common ratio of 3, which term has a value of 162. In a geometric sequence, we know that the nth term is given by the first term times the ratio raised to the n minus 1. And if we insert what we know here, the first term is 2 and the common ratio is 3. And our term value is 162. If we replace a sub n with 162, that'll allow us to solve for n. I'm going to divide both sides by 2. That gives us 81 equal to 3 to the n minus 1. And we can solve this with logarithms, but we can also use a different strategy with this one. 81 is 3 raised to the 4th power. So now we can just equate the exponents. N minus 1 is equal to 4, and n is 5. So this must be the 5th term. In 107, the summation as k goes from 1 to 4 of k squared is 1 squared plus 2 squared plus 3 squared plus 4 squared. Summation means we just add all of those terms. So that's 1 plus 4 plus 9 plus 16, and that will be a value of 30. In 108, we're asked to sum from j equals 0 to 3, the general term 3 times 2 raised to the j power. So that will be 3 times 2 raised to the 0 power is what we start with, plus 3 times 2 raised to the 1 power, plus 3 times 2 raised to the second power, plus 3 times 2 raised to the third power. So we can do some arithmetic here. This is 3 times 1 is 3, 3 times 2 is 6, 3 times 4 is 12, and 3 times 8 is 24, and that's going to give us 45. In 109 through 112, we're asked to write the series using sigma notation. In 109, we can observe that this is an arithmetic sequence. And in an arithmetic sequence, the general term a sub n is equal to the first term plus the common difference times n minus 1, or 5 plus 2n minus 2, or 2n plus 3. If we want to figure out what number term is 85, then we can replace a sub n with 85 and solve. It'll give us 82 is equal to 2 times n, and n is 41. So this series is the sum as n goes from 1 to 41 of the general term 2n plus 3. In 110, we have a geometric sequence with a ratio of 1/2 because we multiply by 1/2 to get from one term to the next. So the general term is the first term times the ratio raised to the n minus 1, and we don't need to figure out what number term this ends with because the series ends with plus ... which means that it goes on infinitely. So we can just write this in sigma notation. N starts at 1 and ends at infinity, or ends never is what we can actually say, and the general term is 640 times 1/2 to the n minus 1. In 111, we can observe that our denominators form an arithmetic progression. So the arithmetic progression is first term of 3, and then we add 2 times the common difference, or rather the common difference times n minus 1, and the common difference is 2. And so the denominators have a general term of 3 plus 2n minus 2, or 2n plus 1. So that means that the general term in our sigma should be 1 over 2n plus 1, and n starts with 1, and we see by the plus dot 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 at the end that this is an infinite series or has no end, so the upper limit of summation is infinity. In 112, we can observe again that we have a fractional value here, but our denominators here are just all perfect squares. So, for instance, this one is 2 squared, that's 3 squared, 4 squared, 5 squared, and we end with 10 squared. So that means that the general term for this sigma is 1 over n squared, and if we choose to start at 2, that just makes it easier, and we're going to end at 10.